everybody, happy Tuesday. Today we're going to go through our last section of material in our trig unit. And what we're going to be talking about today are inverse trig functions. So if we know the sine, cosine, or tangent of an acute angle in a right triangle, what we're going to be doing today is using inverse trig functions to find angle measures. So what we've been doing up through now is we've been finding sine, cosine, and tangent ratios, or we've been using those ratios to find missing side lengths. So what we're going to be focusing on today is finding missing angle measures. So for the first slide here, I've given us for number 1, the sine of angle B equals 0.47. So I want to know in this problem, what would be the measure of angle B to generate a ratio of the opposite leg length over the hypotenuse to be about 0.47. Now, the way that we're going to figure this out is we're going to kind of undo the sine of angle B. Kind of like when we solve an equation, we need to undo multiplication with division. We're gonna undo the sine of angle B. So how I'm gonna show that, it's gonna be a little bit different than kind of undoing multiplication or division. I'm gonna write sine and I'm gonna write an exponent of -1. And how you would read this out loud is the inverse sine. When you see an exponent of -1 attached to a trig ratio, this means inverse sine. And we're going to input into this inverse trig function the ratio of sides that we were given, 0.47. Now, you absolutely positively need a calculator for this. So, what I've done is I figured out, if you don't have a scientific calculator, what you could do is in your Chromebook browser, just go to Google and Google calculator. I zoomed in a little bit to make it a little bit bigger, but this is what pops up if you Google calculator. And I want to make sure in the calculator, let's see, where's my pointer, that I'm on degree mode. So I'm going to click degree mode and make sure that's darkened. And in order to input inverse sine, this says INV, so that's inverse. So I'm going to click inverse. And then see how sine, cosine, and tangent now change to have an exponent of -1. So I'm gonna click inverse sine because that's what I want to do. Inverse sine is also called arc sine. Those are basically synonyms. Like inverse sine and arc sine mean the same thing. There's 2 different ways in math to basically write or notate that you're taking the inverse of sine. So arc sine means inverse sine. And the calculator's waiting for you to input, what do you want to take the inverse sine of? So I'm going to punch in 0.47, push enter, and I get about 28. That is the degree measure. So what that means for this problem is angle B is about 28 degrees. So just going back to the notes, what this equals, what we just found out by punching it into the calculator, is this equals 28 degrees. So B would be 28 degrees about to have a ratio of the opposite leg length relative to this angle over the hypotenuse to be about 0.47. So we're going to continue on here. So for number 2, it says cosine of A equals 0.29. I want to know what's the measure of angle A. So I'm going to take the inverse cosine. I basically undo the cosine. And what I'm going to input into this inverse is the ratio of sides that I was given, the 0.29. I'm going to go ahead and do the same thing, punching it into the calculator. I'm just going to show you on my web browser here. So I'm gonna touch inverse, then punch the cosine now we're dealing with. Arc cosine means the same thing there as inverse cosine. And I'm gonna type in 0.29, push enter. So this would be about 73 degrees if we're rounding to the nearest angle measure. And then the last one says the tangent of angle C equals 1.9. We want to figure out what is the measure of angle C. So in order to isolate C or solve for C, we have to undo the tangent, which is us taking the inverse tangent of the ratio of sides that we are given, which is 1.9. It's just that these ratios are in decimal form, not fraction form. And if we go ahead and do the same thing, punching it into our calculator, rounding to the nearest whole degree, we're going to get about 62 degrees. So if you don't have a scientific calculator, you can definitely use your Chromebook. I have an iPhone, so if I'm on the scientific calculator on my iPhone, it's basically the same thing, except instead of like inverse at the top left corner, there's a second button. So I click second, and then what pops up is like inverse sine, inverse cosine, and inverse tangent. If you have any questions on like accessing these buttons on a calculator, please email me and please reach out to me, because you will need a calculator for this section. Okay, so we're gonna move on to the next couple of examples here. So for number 2 down here, it says, use the diagram below to find the measure of angle A. Round your answer to the nearest degree. So now I have a triangle, and I need to look at the sides that I'm given in relation to the angle I wanna find. So is 5 the opposite leg, the adjacent leg, or the hypotenuse of this triangle? It is the adjacent leg relative to angle A. What is side length of 13 in relation to this angle? Is this the adjacent leg? Is it the opposite leg? Or is it the hypotenuse? Since it's across from the right angle, this is the hypotenuse. So if we think about SOHCAHTOA, what trig ratio has adjacent and hypotenuse in it? Cosine. So the cosine of angle A is equal to, cosine is equal to the adjacent leg length over the hypotenuse. And what we're going to do now is we need to figure out what the measure of angle A is. So I'm going to take the inverse cosine of the ratio of sides that I wasn't given it in this problem. I had to actually generate this myself. But now that I know it's 5 over 13, that's what I'm going to input. If you want to divide 5 divided by 13 and figure out what this decimal is first, you could do that too. But again, I'm going to want to input that into the calculator and then round. To the nearest whole, that's going to give me about 67 degrees. So for the next one, it says, use the diagram below to find the measure of angle B. Round your answer to the nearest degree. Again, we want to start the same way. So what is this side length of 5 in relation to angle B? Is this the adjacent leg, the opposite leg, or the hypotenuse of the triangle? 5 is the adjacent leg. What is 4 in relation to angle B? Is it the adjacent leg, the opposite leg, or the hypotenuse? It is the leg across from angle B, so it's opposite. If we use SOHCAHTOA, what trig ratio has opposite and adjacent in it? Tangent. So we're going to set up the tangent of the acute angle we're referencing. Tangent is equal to opposite leg over adjacent leg. And we need to figure out what the measure of this angle is. So we have to undo taking the tangent of angle B. And the way that we show that is by taking the inverse tangent of the ratio of sides that we generated in this problem. We're going to go ahead and punch this into the calculator. If you want to first figure out what 4 divided by 5 is as a decimal, you could, or you could just punch this in directly. And we are going to round to the nearest whole. So we get about 39 degrees. The next one we're going to take a look at is a word problem. So it says a bird rises 20 meters vertically over a horizontal distance of 80 meters. What is the angle of elevation? So I want to draw a triangle. I know that angles of elevation are drawn up from a horizontal line. So what I'm looking for is this angle of elevation. The bird is kind of traveling along this path. It's rising 20 meters vertically. So which is the vertical segment that I drew? It's this one. So I'm going to label that 20 meters. The bird's rising over a horizontal distance of 80 meters. So which is the horizontal segment? This one down here, I'm going to label that 80 meters. Now I want to figure out the angle of elevation. So I need to figure out this angle measure. So relative to this acute angle measure, what are the 20 meters and the 80 meters? Well, 20 meters is the opposite leg. 80 meters is the adjacent leg. What trig ratio has opposite and adjacent in it? Well, again, that's going to be the tangent. So the tangent of x, I let that angle be x, equals tangent is opposite over adjacent. We need to figure out what x is. So I basically have to undo taking the tangent of x. And we show that by taking the inverse tangent of the ratio of sides that we came up with. Could also reduce this to a fourth if you wanted to. We're going to punch that in the calculator. Round to the nearest whole. We get about 14 degrees. All right. The last two examples are going to be a little bit different. We are asked to solve each of the following triangles. When the directions ask us to solve a triangle, it means to find all missing measures of that triangle. So it means to find all missing angle measures and all missing side lengths. So, the things that are unknown to me in this triangle is the measure of angle C. I don't know. I don't know the length of AB, and I don't know the length of BC. Oops. So that's what this problem is kind of indirectly asking you to find. It doesn't actually list these things, but when the directions say solve a triangle, you need to find everything that's missing in that triangle, all missing angles and all missing side lengths. So the first thing that I'm going to do, I think is pretty easy, is to find the measure of angle C. We could use triangle sum theorem. We know that 26, 90, and angle C added all together have to be 180. Because this is a right angle, I know that angle A and angle C have to be complementary. They have to add to 90 because plus 90 would give you a total of 180. So I could do 90 minus 26, which would just be a little bit of a time saver. And I get 64 degrees. So that one's pretty easy to get. 64 degrees would be this angle measure. Now, what else I have to do here is I have to find these two side lengths. I'm just going to let them be variables. So when I set up my equations, it's a little bit simpler to write. And I'm going to maybe start out by finding the value of x. So I want to use the values in the triangle that were given to me. So I have an acute angle of 26 degrees, X in relation to the 26-degree angle is the opposite leg. 4.5, the other side that I know, is across from the right angle, and that is the hypotenuse. So what trig ratio has hypotenuse and opposite in it? That's sine. So I'm going to take the sine of the acute angle, so we know the angle measure here. Sine is equal to opposite over hypotenuse. Once I set up the proportion, I'm going to go ahead and cross multiply. Again, showing my exact answer and then putting it into the calculator and rounding. Angle measures, if we're not told, we're always going to want to round to the nearest whole degree. And side lengths, when not told, we're always going to round to the 100th. So I would go ahead and again put this in the calculator. And I would find that this is about 1.97. So BC is about 1.97. So the last thing I need to find is the measure of of side length, Y, which is AB. And again, I want to go off the exact values that I'm given in the diagram, not a rounded value. So what I'm going to do here is I need to find Y, and in relation to this 26-degree angle, Y is the adjacent leg. Again, I'm going to go based off of the hypotenuse because 4.5 is a nice exact value. So what trig ratio has adjacent and hypotenuse in it? Well, that's going to be cosine. Of the acute angle, cosine is equal to adjacent leg over hypotenuse. So once I set up that proportion, I'm going to go ahead and cross multiply. I'm going to go ahead, punch that into the calculator, and I'm going to round, which gives me about 4.04. So again, my answer contains 3 measurements, all of the missing angles and side lengths that were not given to me in the diagram. Now, the next one is set up slightly differently than the first one. So the first one, you were given one of the acute angles and one side length. In problem number 2, you are given none of the acute angles and 2 side lengths. So for this problem, I'm going to start it a little bit differently. I am going to start by finding the one missing side. But actually, I'm not going to do any trig because remember, we never set up the sine, cosine, or tangent of a 90-degree angle. It's always an acute angle, and right now I don't know any of the acute angles. So what I'm going to do first is use Pythagorean theorem, which is the 2 legs squared and summed together is equal to the hypotenuse. So the hypotenuse in this triangle is 28. That's going to be the C value. The 2 legs that I don't know, one that I don't know, sorry, is X, and the other that I do know is 19. You could flip the order of the legs if you want to, but 28 definitely has to be in the C position. I'm going to pick up my calculator and square 19, which I get 361. I'm going to square 28, and I get 784. I'm going to subtract 361 from both sides. So I get x squared equals 423. I'm going to take the square root of both sides. I'm going to, again, round to the nearest 100th. So UM is about 20.57. Again, I'm only looking for the positive root because x is a side length. So technically, yes, in this equation, we would get plus or minus 20.57, but this value can't be negative 20.57. So I'm kind of just nixing that negative value because I know it can't be a negative side length. So that takes care of the one missing side. Now, the other two things that I need to know are the measure of angle E and the measure of angle U. I need to figure out the two acute angles in this triangle. So pick one to start. You have two, you need to choose one of them. So I'm going to choose angle E. And based off of these nice exact values, in relation to angle E, I'm going to label the 19 and the 28. So 19 in relation to angle E, that's the one I chose to work on first. 19 is the adjacent leg, 28 still the hypotenuse because it's across from the right angle. What trig ratio deals with adjacent and hypotenuse? Well, that's cosine. The cosine of this acute angle, which at the moment I don't know what number it is, so I'm just going to use the vertex letter. The cosine of angle E equals, cosine is adjacent over hypotenuse. To now solve for angle E, I'm going to undo taking the cosine of angle E. And how I'm going to do that is use an inverse trig ratio. So, or an inverse trig function, I should say, sorry. So I'm going to take the inverse cosine of the ratio of sides that I figured out. I'm going to go ahead, punch this into my calculator. I'm going to round to the nearest whole. So I get about 47 degrees for the measure of angle E. Now, we need to figure out the measure of angle U. So I do want to make sure that all three of these angles are going to add up to 180 so that a triangle's angles all add to 180. So I know that this isn't exactly 47, but I am just going to use triangle sum theorem in order to find this missing angle measure. Or if you want to take it, if you want to like skip one step, remember angle U and angle E, these two acute angles in the right triangle, need to be complementary. So what I could do to find the measure of angle U is I could subtract 47 from 90, because again, these two angles have to be complementary, which means they have to add up to 90. So if I take 47 away from 90, I'll be left with the measure of angle U, which is going to be 43 degrees.